Today, I'm going to be talking to you about data modeling. So as Ashish has kind of alluded towards, modeling your data when it comes to databases is really important. It's a really important step to ensure that your applications perform as you need them to. And I'm going to do that with an example. I'm going to apologize now because my example is based on a pizza restaurant. So if it's near to a mealtime for you, wherever you are in the world, and you're hungry, I'm sorry, please stay with me for the next 15 minutes or so. So what we're going to model is the database that's going to be behind some kind of online pizza ordering system. So we're going to have customers that's going to hold some customer information. Customers are going to have orders. Each order will have a set of items, so the things that people are actually ordering, the pizzas that they're ordering. And then we're also going to have addresses as well. So a customer may have multiple addresses, and then each order will actually be related to a single address, the address that order was being delivered to. And we're going to model the same use case in a relational database, in RDS, and also in DynamoDB, and we'll look at the differences between the two. So as Ashish kind of talked about, historically, if you were storing data before the world of computers, you might use something like a filing cabinet, and you might put all the pieces of paper in the filing cabinet for each individual order. You might have a piece of paper for the customer, but this started to bring a lot of problems because you need a lot of space to store all these filing cabinets. If you need to update any information, it becomes very difficult, quite intensive, because you've got to go and find the piece of paper. And if you need to change the layout of the data that you're storing, that can also get quite tricky because you need to, what do you do with all the data that's already there? How do you add new pieces of information? So when computers came around and this was the only method of storing data, it needed to be rethought about how we stored data. So if we were to take that same method of storing data in a filing cabinet and apply that to a relational database, we'd end up initially with something like this. And to be clear straight off the bat, this is a bad way to design a database. And I wanted to talk about the bad way before we get on to the good way. So hopefully you can see straight away some of the problems that will come with this. Obviously, there's a lot of duplicated data there. And as Ashish talked about, when relational databases came around, storage was quite expensive. We've got the big IBM mainframes, moving that around, storing data. That was really expensive relative to the compute. So duplicating data in this manner would give you a really high storage cost. Obviously, if you need to go and update the data, that then becomes really tricky, because if I wanted to change my name in this database, I've got to find every record in the database and update each record individually. And also, as we start to add additional columns, we're adding additional columns that's going to affect every single row in our database. So this is really bad, to be absolutely clear. This is not a good way to design data. And that's where relational databases came in. And a relational database is just your data modeled as a set of relations. And that's the most important thing to remember when you're modeling with a relational database, is to start with the model. So start with the actual data models you've got in your database and then normalize the data. And what I mean by normalize is just that you want to store each piece of data only once and then reference it from any other place where you need that information. You're creating relations between your data. And that helps to minimize the duplication of data. It lowers your storage cost. Again, like I said, at the time when relational databases came around, the storage was the most expensive part of the data. So what does that look like for our pizza restaurant? So, well, we're going to have a customers table that's going to hold our customer information. Now, obviously, in the real world, you may have more columns in here. I've just condensed it a little bit to fit on the slide. Our customers would have orders. Our orders may have a set of items, and then we also have an address table as well. And you can see now we're storing each piece of data only once. So the name is only stored once, the address is only stored once, and then we're referencing from place to place. And then references are what we'd call foreign keys. And you can think of a foreign key simply as a link between two tables. It just links a column in one table to a column in another table. So you can see that in the order table there, we've got a column in our order table called customer ID, which is 1, and that is referencing the row for customer ID 1 in our customer table. Now, if you want to retrieve data from multiple tables at the same time, you can then do what's called a join, and you can join your tables together at the point of querying. So yeah, that's the most important thing to remember when you're modeling for relational databases, to start with the model and normalize your data and minimize the amount of data duplication you've got. You only want to store each piece of data once. The other thing the relational databases give you is what's called referential integrity. So if I was to try and insert a record into my order table in this data model, and I tried to insert a customer ID of say 5, that the database would stop me doing that. The database would say that's an invalid thing to do because I don't actually have a customer record with an ID of 5. So it really helps to improve the integrity of your data, as well as minimizing duplication and the storage costs and all that other good stuff. So that's relational databases. Start with the model, normalize your data. So to get onto NoSQL now, so my background is actually in relational databases before I found NoSQL. And when I first started working with NoSQL, I just saw it as a way to store any data in any format. So because there's no schema, I just understood that as a permission just to store anything in any format. And that's technically true. You can just store anything. And if you're doing a demo or a proof of concept, that can be fine. But once you start to get to production scale, just storing data in that manner without thinking about it first can actually start to cause a lot of problems. And with things like DynamoDB, it can actually get quite expensive if you've not modeled your data correctly. Another thing that confused me, at least with DynamoDB, was the concept of tables. So from a relational database background, you've got a set of tables and they relate to each other. But with DynamoDB, AWS actually recommends to use as few tables as possible, because you can't join between your tables. DynamoDB prevents you from doing that. And that's simply to allow you to scale. So a join operation in a database is actually quite a intensive thing to do. It's quite computationally intensive. So DynamoDB just stops you being able to do that. And what that means, if you're starting to model complex use cases, it leads you to what we'd call single table design. And that's where you store multiple types of data in the same table, and you're almost pre-joining your data. So you're storing data together that needs to be accessed together. And because now in the world of cloud, storage is actually relatively cheap, and it's actually compute, your servers, your applications, that is more expensive relatively, which is the complete opposite of relational databases. So what that means is it actually can be more performant and more efficient to store the same data twice, because you're going to access that data together. So the absolutely most important thing for DynamoDB is to start with your application access patterns. So before you start doing anything, think of the questions that your application needs to answer, and let them questions drive how you model your data. Because DynamoDB doesn't support flexible querying, so you can query on any column at any time, you really need to spend time thinking about your upfront design. So for our pizza restaurant, I've identified 5 things that our application needs to answer. We want to be able to get data about a specific customer. We want to be able to get all the orders for a customer, all the addresses for a customer, a specific order, and then all the items for an order. And these are at least initially, the access patterns that I've identified for my application. And like I said, this is the most important thing. This is how you would start to build a DynamoDB data model. So what does that actually look like? Well, this is, there's a really great tool called NoSQL Workbench. That's an Amazon tool that allows you to do data modeling locally on your machine. And this is what I've ended up with. So there was a question in the chat about, can you change your partition key? So one of the things I always try and do is, instead of giving my partition key a specific name like book title or customer ID, to just use PK, a partition key. And that gives you that flexibility to be able to store different partition keys. So you can see here, I've got one partition key for my customer, which is customer-james@visa.com. But then I'm also storing orders in this same table. And my orders are stored under a different partition key, which is order-order 001. And then I've got a sort key there just to allow me to sort the data under the individual partition. So what I'm doing here is I'm storing data together under the same partition that I'm going to need to access together. So, and there's a couple of different ways you can do this. This isn't, you could do this in numerous different ways. So for the customer detail access pattern, my application needs to be able to display data on, say, an account page. So when you log into Amazon and you see your account page, you'd see all the information about you as a customer and maybe your addresses as well. So I've stored my customer data and my addresses under the same partition. The same goes for my orders. So I've stored, likely I'm going to want to retrieve my orders and my order items at the same time. So I've stored my orders and my items under the same partition. Now you could store your customer data and your addresses and your orders all under the same partition. So in this case, I could have stored them all under the customer partition. But with what Ashish was talking about around hot shards and trying to spread your data out as much as possible, that's the reasoning for doing that. So I've spread my data out across as many partitions as possible to allow me to spread the load across lots of different shards. So you can see on the left-hand side there the different queries that I'd run to get the specific bits of information. So if I wanted my customer data, I'd look for my partition key of customer-james@visa and a sort key of #customer data, and that will give me just that one row in the database. The same for the addresses and the orders for retrieving a specific order and for retrieving the items for an order. I could actually retrieve my customer data and all the addresses in a single query by just doing a query on just the partition key for my customer. And that would then give me my initial customer data and all my addresses with one query. So it's quite a powerful way of structuring data. Now you're probably thinking, how am I going to get the all of the orders for a certain customer? And that's where secondary indexes come in. So you can apply a secondary index to your DynamoDB table, and that allows what DynamoDB does behind the scenes there is it actually creates a second table that you don't need to worry about. You don't see it, but behind the scenes it creates a second table and it duplicates all of your data into a second table. So you can see there's a column there over on the right hand side called GSI1 PK. So that's the global secondary index 1 partition key. So that's me creating a secondary index. And what DynamoDB will actually do behind the scenes then is actually create a second table that would look something like this. So it only pulls data into this global secondary index that has the partition key populated. So you see I've got 1, 2, 3, maybe 9 rows in that table there. But because I've only populated the GSI1 PK attribute in one of the rows, it only pulls one row into this other table behind the scenes. So then when I want to list all of my orders for a certain customer, then I can just run a really simple query on my secondary index, just say, give me everything from this secondary index where the customer is customer-james@visa.com. So that's, again, there's lots of different ways you could model this same use case. This is my opinion on how you would do it. I'm happy to answer any questions in the chat or offline. So I just quickly wanted to touch on when you would choose SQL versus NoSQL, because this is something that happens quite a lot. And you can see with what we've just modeled, you could actually use both for the same use case. There's a couple of points I've put on here. The big one for me, at least, when I'm talking to customers, is what Ashish kind of referred to earlier, is around the transactional integrity and ACID versus base. So if you've got an accounting use case or a financial use case, or you need to know when you store data that data is definitely stored instantly, then you're probably going to want to move more towards a database that supports ACID transactions, which would normally be a SQL database. The other use case will be if you've got any complex or ad hoc query requirements. So if you're doing custom queries for maybe analytics, then you will probably move more towards SQL than NoSQL. But the final thing I just wanted to show is a really simplified architecture diagram, and just to show how the two can actually work together really well. So in our pizza application, our actual application, our actual website may use DynamoDB as its primary data store because it's fast, it's predictable, it's got really good performance at really high scale. But what we might do behind the scenes is actually stream our data out of DynamoDB and maybe move it into a relational database as well. So we're almost creating a read replica of our DynamoDB table. It's kind of what we're doing there. And that would need to be configured. That's not something supported out of the box, to be clear. And we've got this separate read replica that our business users, our analysts, can then use to do custom queries. And this is a pattern I've seen quite a lot, is where you've got your primary data store, your web application data store is Dynamo because it's so fast, it's predictable, it's low latency. And then you create a replica of your data to actually do custom queries and any custom analytics. So that's a whistle-stop tour of data modeling. As Ashish kind of said, especially with DynamoDB, there's probably a 2-hour session in DynamoDB on its own. I love talking about Dynamo. So if you've got any questions or any follow-ups, yeah, please feel free to let me know.